How's it going, Ding Dongs? Welcome back to Ding Dong Drift. In today's video, I'm gonna see if I can create critical engine parts with a 3D printer. Let me show you what I mean. So if you've been watching the channel, you know that I 3D printed the entire wide body, front and rear, and a whole entire bumper. I also make and sell engine covers like these. These are 3D printed. These are 3D printed. That's 3D printed. So all this stuff, the filaments that we have now, is able to withstand engine bay heat, no problem. You can see I've had this on my car for almost 2 years, and there's absolutely no issues with it. There's no warping, nothing at all wrong with these parts. So what do I mean by critical engine parts? Well, I'm gonna try to make this thermostat housing. You can see it's already plastic from the factory. This is probably fiber reinforced nylon. I have something similar thanks to Bamboo Lab that just released their PPA CF. And I make this 3D printed. And if it does work, can I make other stuff 3D printed that will help me in the future when I want to make a rear mount radiator? Let me walk you through the process of how I'm going to make this piece. We'll test it out and see if it's able to withstand what I need it to do. So I changed it to medium-sized objects or medium and large objects. It seems to scan better when you do it that way, except it's scanning obviously like the whole entire table and everything around it. Let's try now. There we go. Super easy to scan. Scanning the whole table basically. I didn't even put any scanning spray on this because I literally only need the holes and like the shape and angle of the tube. Don't need a full scan. Just need close enough. All right, I think I have everything scanned. Take a look, looks good. Let me show you. We have the angle, we have the holes, and we have the size and everything. That will verify eventually anyway, so let's clean up the scan. I'm just gonna delete all the stuff around it and bring this into my modeling program. All right, so I'm in my program of choice, which is Maya. People always ask me what program should they use. It literally does not matter. Try them all out. They all have free trials, and pick the one that you like the UI of, because they all can do the same thing. They can all create the same stuff. So I import the scan and I orient it as best as I can so that it lines up with at least some of the axes, because it's a lot easier to model when something's straight rather than something is angled. And then I just start modeling. Start with a cube, scale it to approximately the height of the flange, and then I stretch it out to the width and length of the flange. Then I bevel the edges, move some vertices around just to get the generic shape, and then do a little bit more beveling to smooth it out. Add a sphere. I'm doing this in a very basic way. Usually I like to extrude, but I just wanted to show you guys how you can start with something super simple with just basic shapes. You can see adding a cylinder here, getting it lined up approximately to the right size, adding some edge loops, then creating the actual tube, extruded the lip. Now I'm going to start using what's called a Boolean. You can see it duplicated there. And the Boolean basically combines objects together at their intersections. So you can see I'm combining the sphere and the cylinder, and I gave them both some thickness. And then I was left with this mess of edges that don't line up, so I had to go in and clean these up a little bit. Honestly, I should have done this the usual way I model it, but yeah, this ended up being more work than modeling it correctly. So I have an education in game design, so I prefer modeling things very low poly. And I also like clean geometry. That's why you see me moving these vertices around, trying to get a nice edge flow. This stuff does not matter for 3D printing at all, but it just makes me feel good inside that my edges and the vertices are clean. Like you see, I delete all the little edges I don't need, clean everything up, because I want it to look good. Again, completely pointless for 3D printing, but it just works. So you see I'm extending this edge here to cut a hole in the flange, and then I'm able to combine these edges. doing a vertice merge, and then just increasing the threshold until they all merge together. I mean, at this point, the piece is done, but obviously I have to go through it, clean up all the edges, because my OCD will not let me just export this. So once I have it basically modeled, very low poly, I go through and I crease the edges that I don't want to be affected by the smooth mesh, because what I do is I model low poly and then I do a smooth mesh preview, which smooths the whole model out. I had this weird issue with this edge here. There was a hidden face there. But you could see how smooth everything looks now. So I go through, crease the edges that I want to stay hard, and then just verify dimensions and stuff and bolt holes and make any changes, and then cut the bolt holes and more edge cleanup. And the last thing to do is add the little nub detail that sticks out, so that it's basically like the hose stopper. I measured how far away from the edge it's supposed to be, and then just add a little edge loop and extruded these tiny little details, and then just cleaned up some more geometry so that things are smooth looking. And now I can do a smooth mesh preview to polygon conversion. And it's done. Let's go see if this fits. So this is obviously just PETG, just to test fit if it fits. Now comes the dirty part. I gotta go take the cooling system apart. So I actually have a tiny little fluid pump. I think this is for like washer fluid. And I'm gonna try to pull some of the coolant out so that I don't spill a bunch of it. And there we go. Wow, that's fast. I have the splitter, keeps the floor clean, catches everything. Nice. Hell yeah. Didn't lose any coolant. All right, hose fits perfectly, maybe a little loose. Oh, actually I missed that. The pipe gets wider on the end, so I'll have to change that in the design later. Looks like it's holding. Before I print the expensive one, I'm going to close this up, fill it back up with water, and we're gonna see if it's holding, if it doesn't leak. Because the thing that seals the thermostat is actually the O-ring around the thermostat. This is printed very thin, so I'm being very careful not to over tighten it. Start it up and run it for a little bit, and we'll see if it seals. If it does, we can go straight to printing the expensive one. Got some hose water, because that's the best coolant there is. Just watching the bleeder, make sure it doesn't overflow a bunch, because then it's going to be hard to tell if it's leaking or not. And there it goes. Damn it. All right, well, at least we know it's full. So now I gotta close this up, clean it off, let it dry off, and then we'll start it and see if it leaks. So it looks like we're leaking through the hose. So I gotta make the whole pipe just thicker. It's not, I don't see anything leaking. So obviously PETG, not meant for this, not rated for this, but I'm just curious to see how long it will last. Yeah, let's see how long this lasts. I'm gonna let it get up to temperature. Oh, it's starting to leak. See if we can tighten it up a little bit. So it's weird, it's leaking through the bolt and through the hose. The hose clamp is maxed out. Oh yeah, it's leaking everywhere now. Well, wasn't expecting this to last, so that's okay. Let's shut it off. Oh, and the belt's flicking water everywhere. Damn it, crap. I didn't notice this. Damn it, it's so dirty. Now you might be wondering, what is this magical material that will be able to withstand crazy heat and pressure and all this stuff? Well, it's the new Bambu Lab PPACF. Hello. This right here. Bambu Lab claims is nearing the strength and abilities of certain metals. And I looked at the specs and it is like 75% aluminum. And I think this will be just perfect for this type of application. As you can see, the print temperature is very high, 280 to 310 Celsius. Stuff is also very expensive. However, Bambu Lab did send me this for free. Sent me a few of them, review and make products with and all that stuff. So thank you to Bambu Lab for doing that. So like any high temperature material, they have to be very dry. If there's any moisture in these materials, they tend to print pretty poorly. You get a lot of bubbling and all this stuff and porosity and bad adhesion, bad layer adhesion and stuff. So we gotta dry this out. Luckily, since this filament is so high temperature resistant, I can just use a literal oven. So I'm obviously not gonna use my actual kitchen oven. Instead, I have this thing. It's my trusty old toaster. Plop this in there, close it up, and we're gonna go to 250, and we're just gonna put it on stay on so that the timer doesn't run out. We're gonna dry it for, I don't know, 6 hours. I gotta look on the website. There's a recommended time to dry. That's what it says to do, so that's what we're gonna do. All right, as you can see now, it's dark. It's been 7 hours this has been in here. Everything stinks in the garage because I think this toaster had some like plastic in it. Oh my God, it's hot. But I can turn this off now and I'm gonna let it cool off a little bit. I'm gonna close the garage once it cools off a little bit. And then I'm gonna go take it and put it in my little dryer. I'll show you. I have a little dryer that I dry like PETG and stuff with, but this high temp stuff needs higher temperatures. So that's why we did this. Filament doesn't smell at all. It's just my toaster. There's some crap in it. I use that thing to like bake epoxy sometimes and do stupid stuff. This is my dryer. I use this to dry PETCF. It's printing right now, so I'm gonna pick up this lid and put this in there so it stays dry overnight. Or once this finishes printing, I'm gonna start the print with this. Print is done, and it looks like it turned out absolutely flawless. So we're just gonna pop it off. A little bit of support material, pops right off, and it looks perfect. You can see I used this high temperature smooth bed. I didn't wanna use a textured bed because you know that wouldn't seal as well. So I used the smooth bed and we got a beautiful finish on there. It's dark now. Tomorrow, we'll go test this out. All right, it's the next day. It's early in the morning. Today's the last day, I think, that we're gonna have 80 degrees. I think it's supposed to be like 83, which is gonna be the perfect day to test the heat resistance of this new print and the pressure and everything. So the plan is to put this on the engine, obviously fill it up with coolant and let it almost overheat. I'm gonna put the fan safety up to 230 degrees Fahrenheit or about 115 Celsius, I think. Just gonna let the car idle in the driveway for however long. We'll see what happens. Just look how good this print looks though. Freaking amazing. It's like shimmering. You can't see any of the layer lines, nothing. Freaking awesome. All right, let's throw it on the car, push it outside, and just let it idle. We gotta put new bolts on this. Or new nuts, let's see. Okay, I hear cracking. I'm gonna have to add more perimeters around the bolt area. Let's hope it didn't cause a leak. Okay, the pipe definitely fits a lot tighter now than it did earlier. So I need to loosen the clamp more. So we got a problem. See that? The print is sweating through the top here. And I think the reason is I didn't put any supports there. It was kind of porous in that area. Yeah, the water pressure is leaking through. So this piece will not work. So I gotta go either redesign it or reprint it so that the top area is a lot smoother and doesn't have this issue. Back to the drawing board. Got the piece off the printer. Now we can see how I changed the design. So you see the top is now more pointed. And if we look inside, print finish is a lot smoother. There's no more pieces hanging down. It's a lot cleaner now. But also what I did was I increased the width, the extrusion width to 0.5. It used to be 0.42. So it's a lot thicker now, and the extrusion multiplier is now 0.99, which used to be 0.96. It's not a drastic change, but it is a change. And then also, remember how you heard the cracking? These pieces where the bolts go are now completely solid all the way through. I added a little modifier there to print those solid. Throw it on the engine, fill it back up, see if it holds. If it doesn't, I'm printing another one with a 1.05 extrusion multiplier and 0.6 extrusion width. So 50% thicker extrusion than the nozzle. Hopefully that works. Oh no, it's starting to leak at the top here. Thought this was gonna be easy, but looks like this is gonna be a little more difficult than I thought. Hopefully the issue isn't the filament being, you know, carbon filled, because I've seen plenty of videos of people achieving full pressurization with, you know, PLA and PETG and everything else. I just want to see where it's mostly coming out of. Right out of the seam. So where the, see that? Right where the joint is on the print. So this might be a case of using random joint instead of scarf joint. All right, well, it's dark now and the print finally finished, but I think 1.1 or 10% over extrusion was a bit much. So overhangs look terrible, but maybe it will seal. So what I'm gonna do is just sand down this just so it's smooth so the pipe can actually seal to it, and we're gonna throw it on and we're gonna see what happens. I'm printing another one right now, 5% over extruded, so we'll see what happens. All right, gave it a quick buff with the angle grinder and some 320 grit sandpaper. It's actually insane how strong this filament is. It feels like metal, like grinding it feels like grinding aluminum. This stuff is crazy. I cannot wait to use this for some like body modification stuff. This is gonna be really exciting. All right, here we go. What is this, test number 3, 4? I can't remember anymore. Well, so far no leaking. So that's all we needed. More extrusion and thicker width. Oh, and one more thing I did was random seam. So there's no more seam, because remember it was leaking through the seam here. So I did random points. So there's no one seam. It just stops and starts layers at random points. We're still Gucci, baby. We're still good. What's the temperature? We're at operating temperature, 85, baby. 85 Celsius. So now we gotta let it heat soak. Everything heats up a lot. Thermostat opens, yep, it's hot in here. Everything's hot, this is hot. Once everything's heat soaked, the temperature should start creeping up. Oh boy, this is exciting. Hopefully I don't blow a head gasket. Nah, it's a freaking 1UZ, you can't blow a head gasket. Man, it's gonna take a while to heat soak this radiator. You can see some of the spilled coolant that's on the fins. It's starting to evaporate. So the radiator is nice and hot now, super hot, but the coolant temperature is still not rising. It's 87 right now. So like I said, we want to get to 110. That way we know this thermostat housing and this filament is not a failure point. It's better actually to idle than it is to like drive around, because driving around would just force air through the radiator and cool it more. So sitting in the garage, perfect. Lots of stagnant air, minimal cooling. All right, I just held the throttle for a little bit. It is finally heat soaked and the temperature's rising. Just gonna keep holding the throttle a little longer. Hopefully I don't run out of gas, because I can't remember the last time I got gas in this car. But still no leaks. What do we have for temp? 93, it's going up, baby. Oh man, this is so exciting. No leaks at all. 95. All right, so we are at 98 Celsius or 212, I think, no, 205 Fahrenheit, I think. This is where the fans usually come on. So we're gonna keep going. Everything's heat soaked, everything's super hot, still holding, we still got no leaks. Super exciting. We're at 99 Celsius now. So once we hit 100, that's 212 Fahrenheit. That's the boiling temperature of water. 100 right now. I'm kind of scared to stand close to it because I don't know how high the pressures are. 101. We're at 103. ECU's starting to freak out. It's telling me that's alert temperature. And we're at 104 Celsius, so the fans are gonna kick on at 110, 105. Yep, 106. Holy crap, boys. This is insane. Still holding. How does it feel? Wow, that's crazy. It's still not hot. The thermal conductivity of that plastic is like nothing. 108. We got 2 more Celsius for the freaking fans to kick on. I'm scared the pipes are gonna burst. Holy crap, the pipes are so inflated. I don't know if you can tell. Our hoses, Jesus Christ, they're like balloons. Shit, I think that's gonna be my failure point. Is the freaking hoses. Okay, no more going near the engine. Okay, from now on, I'm doing this. 109, one more, come on. This is the hottest this engine's ever been. 110, should be 5 seconds and the fans should kick on. Fan's still not on. What the hell is going on? Why is it not turning on? All right, I'm turning it on by myself. I don't get why it's not turning on. It's at 111. PDM's tripping, dude. Holy crap, that's hot. We did it, boys. Did a full heat cycle. Overheated cycle. Safe to say it's now safety rated. Oh, that's why. It's when it's greater than. I should do greater or equal to. That's why. So it was waiting for 111. 3D printed thermostat housings just did a full heat cycle. Still no leaks. But that's gonna be it for this video, ding dongs. This is a great sign and good testing for things that I wanna do next. And if you're still watching, what I am gonna do is pretty exciting. So I've mentioned many times before, but I plan to do a rear mount radiator. And if you wanna do a rear mount radiator, you need to somehow have AN lines go from the front of the engine to the back of the car. And the way I'm gonna do that is I'm going to 3D print this water neck with an AN fitting right here, and this thermostat housing that bolts onto the water pump that will also have an AN fitting. And this was the test for those pieces. That's what's happening later on in the future when I rebuild my spare engine, because this engine has bad bearings or something's wrong with it. I can't remember, it was a while ago. So I'm gonna rebuild that engine because it has less miles than this engine. So I expect the cylinder bores to be better on that engine compared to this one. This one says 320,000 miles. That one only had 160. That one needs a rebuild. And that one is gonna get boosted when ZTech sends me his manifold that he's making. I'm not gonna sell these. It's pointless to sell them. They're 15 bucks on Rock Auto or whatever they are. I don't know what but I am gonna continue testing because I did reprint these. This one is actually printed out of PETCF, which is the same filament I use for the engine covers. However, this filament is kind of brittle. It has, it's very stiff, but it's the same stiffness as the nylon, but this stuff is not as tough. I'm still gonna test it. We're gonna see if it leaks. This stuff is way cheaper. This stuff is $200 a kilo. This is only 90, so half the price. And then I also I'm printing another one. This one's 5% over extruded. I'm printing one that is 0 over extruded because I would like the finish to be better. It doesn't really matter in the end for those products. They're not gonna have a pipe on them or anything like that, anything exposed with overhangs. It's just gonna be, you know, a simple little crossover. The only thing that needs to be clean is the flanges, and I plan to sand them. But yeah, the only thing that's gonna be threaded, there's gonna be an ORB fitting and obviously the coolant sensor. So that's it. I'll explain this more later on when I'm actually making this piece and designing it. So don't worry, more details are coming on that. Update you guys on how these prints do, the PETCF and the 1% and the 5% over extruded and the 0% and all that. Make sure you subscribe, you don't miss that, because a lot of exciting things are coming. Next video is gonna be a new 3D scanner. Very exciting. I'm super excited about it. And thank you again to Bamboo Lab for sending out that X1 and sending out all that filament. If you guys want to check out Bamboo Lab printers, all their filaments that they have, all the crazy engineering filaments that are able to withstand these types of situations, check them out in the link in the description. So yeah, make sure you subscribe. You don't miss that. If you're still here and you're wondering about my health, I am doing great and back on my medication. I'm back on Keppra. Yeah, the doctor said my General epilepsy's back. I basically got lucky for 15 years not taking any medication. I didn't sleep well for 2 days and it triggered a seizure, so back on medication I go. I'll be able to drive in 3 months since the seizure, so it's been a month already. Hooray. 2 more months I'll be able to drive supervised. So I'm not gonna be driving this thing anytime soon because it's gonna get torn apart and gonna get a roll cage and all that stuff. But I will be able to finally drive my daily car. Thank you everybody for all the wishes and all the positive comments. Can't thank you guys enough. I was really surprised about that. Thank you everyone for watching. Check out the Patreon if you'd like to see these videos early, and of course all the exclusive updates and behind the scenes stuff that happens. This is gonna be a Patreon file for the month of November, so free file if you wanna sign up and become a patron. Yeah, I'm just rambling at this point. Thank you everybody so much for watching. Peace out, ding dong, stay sweet, and I'll see you guys next week.
America, America, do you have your passport?